buhay sa kahanginan.
Have a nice day, my dear students. In life, we encountered questions like, do you know why a shorter code is weak while a longer code is a strong personal password in a computer account? Have you ever realized that there are several possible ways in doing most tasks or activities, like planning a seating arrangements or predicting the possible outcomes of a race? Have you ever been aware that there are numerous possible choices in selecting from a set, like deciding which combinations of dishes to serve in a catering service or deciding which dishes to order in a menu? Do you know that awareness of this helps you to form conclusions and make wise decisions? So, I'm Teacher Jenny, willing to guide you in finding answers to these questions and discover wide applications of permutations and combinations through these learning activity sheets. But before that, make sure that you have with you the following: your learning activity sheets, your answer sheets, and your ball pen. So okay, let's go and learn something new.
In our daily lives, we experience a certain situation that describes permutations and combinations. All these things were created by making wise decisions in order to formulate a genuine conclusion. Making and formulating wise decisions and conclusions are important skills needed for learning concepts to problems involving permutations and combinations. So, in this learning activity sheet, you will know more about permutations and combinations and how its concepts utilized in our daily lives. After going through this learning activity sheet, you are expected to solve problems involving permutations and combinations. In solving problems involving permutations and combinations, it is important to know the difference between the two, which can really help you to easily apply the appropriate concept in solving problems. We already knew the following terms like permutations, combinations, fundamental counting principle, n factorial, circular and distinguishable permutations as elaborated already in the previous learning activity sheet. For you to be guided, let us take a look for some important terms as we go through on this learning activity sheet. First, we have permutations. Permutations refers to the different possible arrangements of a set of objects. The number of permutations of n objects taken r at a time is equal to n factorial divided by the quantity of n minus r factorial, where n is the number of objects greater than or equal to r, and r is the number of activities. Another is the fundamental counting principle. It states that if activity A can be done in n sub 1 ways, activity B can be done in n sub 2 ways, activity C can be done in n sub 3 ways, and so on. Then, activities A, B, and C can also be done simultaneously in n sub 1 times n sub 2 times n sub 3 and so on ways. Next, we have combinations. It is the number of ways of selecting from a set when the order is not important. The number of combinations of n objects taken r at a time is equal to n factorial divided by the quantity of n minus r factorial times r factorial, or the permutations of n objects taken r at a time, divided by r factorial, where n is greater than or equal to r. Another one is n factorial. It is the product of the positive integer n and all the positive integers less than n. N factorial is equal to n times the quantity of n minus 1 times the quantity of n minus 2 until you multiply to 3, 2, and 1. The second to the last term is the distinguishable permutations. It refers to the permutations of a set of objects when P are alike, Q are alike, R are alike, and so on. It is given by the formula P is equal to n factorial divided by P factorial times Q factorial times R factorial times the other factorial if still exists. The last important term is the circular permutations. It refers to the different possible arrangements of objects in a circle. The number of permutations P of n objects around a circle is given by P equals the quantity of n minus 1 factorial. Now, let us discuss each given problem applying the different concepts on permutations and combinations as I mentioned earlier. Let's begin with example 1. In how many ways can 5 people arrange themselves in a row for picture taking? So, here is the solution for number 1. From the given problem, order is important because one arrangement for picture taking is different from other arrangements. So, the concept of permutations is applicable. In that case, 5 people will be arranged 5 at a time for picture taking. So, n is equal to 5 and r is also 5. Since n is equal to r, then the permutations of n taken r at a time is just equal to n factorial. By substitution, we have the permutations of 5 taken 5 at a time is equal to 5 factorial. To simplify further, it is equal to 5 times 4 times 3 times 2 times 1, which is equal to 120. Therefore, there are 120 possible pictures done in the picture taking. Example 2. In a school club, there are 5 possible choices for the president, a secretary, a treasurer, and an auditor. Assuming that each of them is qualified for any of these positions, in how many ways can 4 officers be elected? From the given problem, order is important because one set of officers is different from the other set of officers. In that case, n is equal to 5 and r is equal to 4, since you are going to select 4 officers in each set of officers. Using the formula we have the permutations of n taken r at a time, which is equal to n factorial divided by the quantity of n minus r factorial. By substitution, we can have the permutations of 5 taken 4 at a time, which is equal to 5 factorial divided by the quantity of 5 minus 4 factorials. By simplification, it is equal to 5 times 4 times 3 times 2 times 1 divided by 1 factorial. The permutations of 5 taken 4 at a time is equal to 120 ways. Therefore, there are 120 ways in selecting a set of officers. Another way of finding the number of possible ways is by applying the fundamental counting principle. In this principle, R is the number of activities and N is the number of objects to be arranged. From the above example, selecting a president, a secretary, a treasurer, and an auditor is considered as the number of activities. First, we select for president in 5 possible ways. Then, for secretary in 4 ways, since we assume that 1 is already selected as president. 3 ways in selecting for a treasurer, since 1 is already selected as secretary, and 2 for auditor. Applying the fundamental counting principle, we can have 120 ways in selecting a set of officers. Always remember that in determining the number of permutations of n objects taken r at a time can be solved easily by applying the fundamental counting principle. Example 3. Given the 4-letter word read, in how many ways can we arrange the letters 3 at a time? In the problem, order is still important since any of the 3 letters formed is different from the others. You can select 3 letters at a time from the given 4 letters in the word read. So, the activities are selecting the first, the second, and the third letter. Applying the fundamental counting principle, we have n is equal to 4 and r is 3. So, the permutations of 4 taken 3 at a time is just equal to 4 times 3 times 2, which is resulted to 24 ways. Example 4. Find the number of distinguishable permutations of the letters of the word statistics. There are 10 letters of the word. However, we have to take into consideration that 3 S's are alike, 3 T's are alike, and 2 I's are alike. In order to eliminate the duplicates, we must divide 10 factorial by 3 factorial, 3 factorial, and 2 factorial. Applying the concept of distinguishable permutations, we have 10 factorial divided by the product of 3 factorial, 3 factorial, and 2 factorial. By expansion, we have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial divided by the product of 3 factorial, 3, 2, 1, 2, and 1. Dividing the common factors, we have 50,400 distinguishable permutations. Example 5. In how many ways can 5 people be seated around a circular table? Since 5 people will be arranged in circular form, then we can apply the concept of circular permutations. So, we have n equals 5. Applying the concept of circular permutations, then we have P equals the quantity of n minus 1 factorial. Replacing n by 5, then we have P equals the quantity of 5 minus 1 factorial, or simply 4 factorial. 4 factorial is equal to 4 times 3 times 2 times 1, which is equal to 24 ways. Example 6. In how many ways can a committee consisting of 4 members be formed out of 8 people? In the given problem, order is not important since forming a committee of 4 members is the same on the committee formed with the same people as members. Even if they interchange their positions, they are still the same people. So, the concept of combinations is applicable. Here, n is equal to 8 and r is 4. Applying the formula, we have the combinations of n taken r at a time is equal to the permutations of n taken r at a time divided by r factorial. By substitution, we have the combinations of 8 taken 4 at a time equals the permutations of 8 taken 4 at a time divided by 4 factorial. To simplify further, we have the combinations of 8 taken 4 at a time is equal to 8 times 7 times 6 times 5 divided by the product of 4, 3, 2, and 1. So, combinations of 8 taken 4 at a time is equal to 70 ways. Example 7. How many polygons can be possibly formed from 6 distinct points, no 3 of which are collinear? Since there are 6 different points on a plane, no 3 of which are collinear, then the polygon may have 3, 4, 5, or 6 vertices. We need to find the total number of polygons formed consisting of 3, 4, 5, and 6 sides. The concept of combinations can be applied in determining the number of 3-sided, 4-sided, 5-sided, and 6-sided polygons. Thus, the number of possible polygons, which is represented by capital N, is equal to the combinations of 6 taken 3 at a time, plus the combinations of 6 taken 4 at a time, plus the combinations of 6 taken 5 at a time, plus the combinations of 6 taken 6 at a time. Applying the formula, we have n equals the permutations of 6 taken 3 at a time divided by 3 factorial, plus the permutations of 6 taken 4 at a time divided by 4 factorial, plus the permutations of 6 taken 5 at a time divided by 5 factorial, plus the permutations of 6 taken 6 at a time divided by 6 factorial. By simplification, we have n equals to 6 times 5 times 4 divided by the product of 3, 2, and 1 plus 6 times 5 times 4 times 3 divided by the product of 4, 3, 2, and 1 plus 6 times 5 times 4 times 3 times 2 divided by the product of 5, 4, 3, 2, and 1 plus 6 factorial divided by 6 factorial. To simplify further, we have n equals to 20 plus 15 plus 6 plus 1. Therefore, there are 42 possible polygons formed. This time, try something new on solving problems involving permutations and combinations. So, let us answer activity 1 entitled Mission Complete and try to see on the screen if you have the same answer. Just follow directions. Read and understand each permutation problem, then write your answer on your answer sheet. Number 1. A teacher wants to assign 8 different tasks to his 6 students. In how many possible ways can he do it? You are given few seconds to answer. If your answer is 20,160, then you got it right. Number 2. In a certain General Assembly, 4 major prizes are at stake. In how many ways can the first, second, third, and fourth prizes be drawn from a box containing 130 names? You are given few seconds to answer. If your answer is 272,613,120, then you are correct. Number 3. How many distinguishable permutations are possible with all the letters of the word ellipses? ELLIPSES. You are given few seconds to answer. If your answer is 5,040, then you are correct. There are 5,040 distinguishable permutations. Number 4. How many 5-digit numbers can be formed from the digits 1, 3, 5, 6, 8, and 9 if no repetition is allowed? You are given few seconds to answer. If your answer is 720, then you are correct. Number 5. There are 4 different mathematics books and 5 different sciences books. In how many ways can the book be arranged on a shelf if there are no restrictions? You are given few seconds to answer. If your answer is 362,880, then you are excellent. This time, you will answer Activity 2 in your Learning Activity sheet. Always apply the concepts that involve permutations and combinations. Activity 2, choose wisely, choose me. Directions: read and understand each combination problem, then write your answer on your answer sheet. Number 1. If there are 12 teams in a basketball tournament and each team must play every other team in the eliminations, how many elimination games will there be? You are given few seconds to answer. If your answer is 66, then you are absolutely right. Number 2. If there are 7 distinct points on a plane, with no 3 of which are collinear, how many different polygons can be possibly formed? You are given few seconds to answer. If your answer is 99, then probably you can proceed to the next problem. Number 3. In a 10-item mathematics problem solving test, how many ways can you select 5 problems to solve? You are given few seconds to answer. If your answer is 252, then you're right. Number 4. In how many ways can a committee of 5 be formed from 5 juniors and 7 seniors if the committee must 3 seniors? You are given few seconds to answer. If your answer is 350, then you're correct. Number 5. A box contains 5 red balls, 7 green balls, and 6 yellow balls. In how many ways can 6 balls be chosen if there should be 2 balls of each color? You are given few seconds to answer. If your answer is 3,150, then you are now in the mastery level. Now, you're ready to answer the last activity in your learning activity sheet. If you will get all the correct answers, then obviously, you'll listen very carefully. Alright, how was it? Now let me ask you some questions. Were you able to solve the problems? What mathematical concepts or principles did you apply? Did you find any difficulty in solving problems involving permutations and combinations? Why? In solving problems involving permutations and combinations, the concepts of permutations, combinations, fundamental counting principle, distinguishable permutations, and circular permutations are very important things to master. You can solve the problems easily if you know these concepts very well.
Alright, that ends our discussions. Hoping you've learned something about solving problems involving permutations and combinations. Thank you for watching and continue answering your learning activity sheets. Be yourself and stay safe. Bye!